Hello and welcome to another video. And today we got again candy, and this time something I like. Caramel and sea salt. That is exactly what I like. So thank you very much for that. And let's have a look at the board that we have on our bench today. So let's get this unwrapped. So this time we have an AM4 board. This is an Asrock B550M PRO4, as you can see right there. And the owner told me that there's physical damage and probably around the BIOS chip. So we will have to take a look at that, and we also have to see how this board will behave when trying to boot it up. But let's first go under the microscope then and instantly follow up on what the owner said. So let's have a look now. This area looks like someone has been trying to solder here. So there might be ripped off stuff and also melted stuff, because all of this looks like flux. And the chip looks like it got scratched badly. And we might even have some torn traces. Have a look at the right side here. You can see right there, there's missing solder mask under here. And there's also solder mask missing there and also right there. So there might be knocked off components. This component might be missing, but I don't think, because this pad looks like it's been fluffy all the time. So I don't think that there was one knocked off here. But definitely the chip took a hit. What we can do, this has an SPI header. As you can see, SPI TPM. This header is directly connected to this BIOS chip. What we can do is we can try to put our programmer into here and then see and test this BIOS chip if this is still correct. So let me show you the programmer I'm using. So here's my case where I store all my BIOS stuff. The programmer that I'm using is very expensive. What means it's around $100, something is a little bit more. I really like this one. This is more of an enterprise solution. You can do with a cheap CH programmer, you can do a lot of things that are mostly necessary, but this thing just does a lot of things integrated. Like the 1.8 volts, it does integrated with finding out what BIOS chip it is. It does more like I2C and similar stuff. I just use this also because it's very fast. So you don't need this one, but yeah, if you want to go into doing a lot of my motherboards, this is the way to go. And then there's all of my cables and adapters. We have Asrock. So for Asrock, I've made this adapter plate right here. And all what this is it adapts this pin out, this 8-pin pin out, right there, to an SPI header, which is this header right here. And this we can then plug in to the board. So we have pin 1 marked with the red stripe, and on the board there's also pin 1 marked, but for that we need to go under the microscope to show you that. So pin 1 marked is this corner right there. Let me get tweezers again so I can point at that. Right here at that corner. You see that this pin has like the gray undermarking. That means that this is pin 1. What we now do is we take this connector, making sure that pin 1 is lined up with that. And let's now put this into here. So now our SPI header, as you can see, is on here. That last pin doesn't matter. But every other SPI header is different for different manufacturers. So it's very important that you get an Asrock, or that you make an Asrock one like I did. I have many different ones that I can show you. So on my box I have different ones. Like you can see, this one is labeled Asrock, but I have also one that is for ASUS right here. I have another one that is like for MSI. This one I think is for MSI. No, this is also Asrock programming, but this is for the bigger pitch, for the 2.54mm pitch. The pitch means the diameter from the individual pins where it needs to go on. Then there's my MSI cable right here. And yeah, and like that, I always continue to make new cables in order for me to be able to just simply check BIOSes like that. So let's now then take this board, take the programmer, and what we do, we line up pin 1. Pin 1 in my case is this one right here. It says on the top also. And what I do is I plug it in. This one says pin 1 in the top left, if you follow this marking. So that is top left, pin 1. And we're going to be plugging it in. And now I'm going to be heading to the computer, connecting this up, and let's see each other then in the software. So we currently have the software open, and I will now need to connect my programmer. Just have a long lead that I can connect to there. And now let's see if it can identify the chip. Let's see, is it a 1.8 volt chip? Probably. And it can identify the chip. That is very good. That means our BIOS chip is not dead. But we get a communication error as soon as I'm trying to read from it. Interesting. Let me fiddle around with the connection a little bit and see if I can get a good connection. So I am not able to establish a connection to this chip. So we will have to take this chip off with hot air and see what is underneath it. We might want to solder that chip onto a breakout board and actually see if it's dead or if it's just the soldering under it. So let's do that. So in order to prepare for soldering onto this BIOS chip, let me get some aluminum tape onto here so that we don't burn the header up. We don't need a lot of it. This should suffice. Just a little bit over the connector there. And then we're going to be careful with our hot air. There's probably flux all over the place already. And especially under the chip. But I'm just going to be adding some of my own. And I will also be getting a adapter onto here directly so I have a place where I can solder it onto. So using hot air, 380 degrees, 90% airflow. Let's now remove the chip. I'm very interested to see for the soldering on here. So applying leaded solder wouldn't have done us any favor here, sadly, because there's a ground plane under the chip. There's the chip. Now it's moving. So the solder connection under it look decent, to be honest. Let's solder that chip onto a breakout board. You cannot see that, but let me do that quickly. So this is my adapter board that you can see right here. The chip is soldered on. And now let's see. The area looks fine. So it might be a problem with the chip itself or the soldering was bad. I don't know. But let's put the adapter that we have now into the PC and let's see if we get communication done. So back at the PC, let's now see again. We get that, and we do get a reading. So that does work. So it probably just wasn't soldered properly. So let's run this through and just flash a new BIOS onto there just to be sure. So let's search for a different BIOS. So now on the manufacturer's website, with the B550 PRO4, we go onto support, we go into BIOSes, and let's see now. We're just going to be using one of the newest ones. So let's not take a beta BIOS, but just get a proper one. So we're going to get 3.40, which is from 2024, 23rd of January. Yes, let's download this. And while we were doing that, we get a confirmation of the BIOS chip right here. So let's save this old BIOS file just to be sure. So now we have in our folder, we have the downloaded one and we have the original one. And important is to look that they are the same size, and they are. So we're going to be opening this up now. And now we're going to be writing buffer to memory. And now it's going to be starting with first erasing the chip, then programming it, and then verifying the chip. Seems like the BIOS chip does not want to cooperate with us. So we're going to be just trashing it. Interestingly that we actually got the data off of it, but as soon as we tried to erase and write to it, it didn't want to do that. Because the erase function, all it does is just writing a lot of zeros into every single slot. So you're not actually erasing it, but you're writing to it first. And then it does a blank check that everything is written to 0, and then it does program it and then verifying. So yeah, we are going to get a different chip and instantly solder it onto there. And the device that we have recognized is an MX25U256 35F. So let's see for its data sheet. So the data sheet for this chip. Let's go to the first page. It says it's a 1.8 volt chip, 265 megabit chip. So that is what we need. So let me have a look in my stash if I have a replacement. So let's see, the chips that I got are Windbond chips, 25Q256JVEQ. I think those are 1.8 volt chips. They definitely have the right amount of memory. So let's have a look if they are also 1.8 volt chips. So this is not a correct chip. If we have a JV edition, we have a 3.3 volt 256 megabit chip. So we will have to find a different one. So on a donor board I found this chip 25Q256JW, and I'm pretty sure this is a 1.8 volt chip. Let's now prepare the area. What I like to do, just to be sure, I like to take off whatever solder is on here. So we will take solder braid and also our some flux onto there. So this seems to not be leaded solder because it does not wick off as easily, especially off of this ground plane. So, but it is cleaned now. Let's now apply leaded solder to here. So it will be easy to solder in the new chip. Well, the new good one. So get a good amount of solder on all of these pads. Let's take off a little bit off of that center, so we don't have too much squeezage. So just a little bit, like that. And now I will be hot airing it off of the donor board and putting it onto here. So the chip has arrived. Let's now try to not blow it away and solder it onto here. If I remember correctly, it was the bottom right where this chip was. So where it has pin 1. Oh, please don't move away. And now the chip should be soldered on. You can see all of the pads being liquefied when we push on it, when we twist it a little bit. Get it in the right direction, and that should be it. It went on a little bit crooked, but it should be fine. There's a good amount of tolerance in that. So let's now get this area clean, especially because there's flux from the previous soldering attempt from this. So let's do that first. So the area is nice and clean now, and yet now you can properly see how crooked it is, but it should be fine because it's soldered on and there's pretty surely no bridging. And what we're going to do now is we're going to go ahead again and we're going to be plugging it into our programmer. So let me grab my adapter board, because currently there's an MSI BIOS on there, on that chip, because it came from an MSI board. And before trying anything now, we're going to be putting in the adapter that we have. Now the adapter's in. We're going to be plugging it into our programmer. And let's go to the PC once more and hope that this time everything will work. So chip is now in. Let's see now. 1.8 volt Windbond chip. It gets recognized. Let's read it. So we were able to read out the chip now, and there's all the information. What we're going to do now, we're going to be opening up the file that we need. And now let's write the buffer to memory. It's going to be starting to erase now. This time the erase operation did work. So let's let that finish. Then it's going to be going over to programming and verification. So the chip now has been programmed and verified successfully. Let's now unplug it and see. So now the board has been flashed and has supposedly a good BIOS chip on here. So let's now get this built up. Let's use a 2200G in order for us to have video output and also see for the first time what the passive power consumption on this board is. Who knows, maybe there's even more wrong with this, but it was pretty indicative of what we had here, that there was damage around the BIOS chip and also the chip itself being damaged by us not being able to read. Well, we read the chip once and then everything else failed. So this board does not have any post LEDs, so we will do with the DDR tester. Let's now get the power consumption onto here. So passive power consumption, 120 milliamps. You can see, of course. Let me fix that. Now you can see. So power consumption looks good. Let's hit the power button and see for the postcodes. We got postcodes running. We have 2.5 amps. That looks very good. C3. Let's put a cooler onto here. Oh, there is. Oh, this has LEDs. Very interesting, but at the position that I've never seen them before. Let me get a post screen also onto here in case this posts, but let me put this there. I've never seen postcodes in this position before. They are at the very bottom, and currently we have a CPU and a DRAM LED. So CPU and DRAM LED. Okay. So let's just cycle the RAM onto a different position. And let's try this again. So still the CPU and DRAM. Let's get a different processor in here because we do have the newest BIOS on here. I don't know if they still support the 2200G with the newest BIOS. So let's go for the 3000G, if that might help. So again, CPU and DRAM LED. Let's see now, but the power consumption looks different. Let's see if we go any further now. Now it went out. That is very good to see. That was RAM training, pretty sure. We have jumping current, which is always very good to see. This indicates a boot up sequence. This time we have boot and CPU LED. Let's see if it just takes some time. Yeah, it just takes some time to restart by itself. And let's wait now for a actual post screen then, I guess. And there it is. There's the post screen that we waited for. So 2200G didn't want it to give us a picture, but the 3000G does. And now we have this BIOS splash screen. Let's now put 4 DIMMs of RAM into here. Let's get an NVMe SSD into here so that we see it gets recognized, and also test the Ethernet. So let's do that again now with CPU in here, with RAM, with an NVMe in here. And let's now get the post out of here. I didn't use the main PCIe slot, M.2 slot. I didn't want to get this cover off. I just thought, just plug it into here. And let's see it now go into Windows. And let's also connect an Ethernet cable up to here. Very interesting. All 4 LEDs are now on. This LED sequence here is so weird from this board. Like, the position is weird, and the sequence that this goes through is also weird. We have so many times 2 different LEDs lit up at the same time. Just a second before, we had all 4 lit up at the same time, and now we currently see the reticle going around, meaning we go into Windows. That is very good to see. Preparing devices. So I currently have problems with my display capture yet again in Windows, but it is definitely running. As you can see, we have indication on the numlog, and also I can see both LEDs blinking on the Ethernet port, and we are definitely in Windows. It does react to the power button and everything. I just have problems with my display capture. It is partially because I'm using this NVMe drive with its Windows install on, like, I don't know how many different boards I've used it now. But trust me, this board is working and it's doing all fine. It also has all of the RAM in it now. And yeah, this board was fixed. These BIOS chips actually die on themselves pretty often. So not only when someone has physical impact on them, but them dying themselves is pretty often. So especially the 1.8 watt chip, 256 megabit variant. That one is worth stocking up on, because those die all the time. And I've had it multiple times already. And yeah, I don't even know what caused it in this case. Like, why the owner even tried to access the BIOS in any way. But that doesn't matter for us. We had to fix it, and we did. So, get stocked up on those. A good thing to check the BIOS chips is always see if you out of circuit, if you can program them, because there can be stuff wrong around the BIOS chip itself on the motherboard. So taking it out is always good in order to check them and verify that the actual chip is broken or not. And yeah, maybe I inspired you to also do some adapter cables like I've made them. So, thank you very much for watching. All of my tools that you can buy are linked in the video description. Hope you learned something in this video. This was Mainboard Medic. Thank you very much, and goodbye.